Hi there, welcome to the robot program. I'm Professor E. In this episode, I'm going to show you how you can navigate an obstacle course using a program written in Blockly. You can use any of the Revolution robots for this exercise, but today I'm going to use Six. You can see over here that we've already built our obstacle course. We've put down a foam surface to make it easier for Six to move across the floor. And then we've also got some pylons, we've got some foam blocks, and we've even got a couple of other robots, Darth Vader and Wally. The goal of our robot is to get from between the first set of red pylons out to the second set of red pylons, moving between all of these obstacles. To get started, I'm going to load the EasyBuilder software, and I'm going to go into my bookmarks menu here and click on Example Projects. You want to open up the project that's the Bear project for your robot. So if you're using JD, open the JD Bear project. If you're using Six, open the Six Bear project, Roly Bear, and AdventureBot, open the Bear project for AdventureBot. Just click the green Open button, and this will open up the Bear project. The Bear project is a nice clean workspace with minimal controls. So I'm going to go ahead and turn on Six. Give him lots of room. Down on my Wi-Fi connections, I'm going to connect his Wi-Fi connection. Good, and then click the blue Connect button to initialize. Excellent. Okay, so Six is ready to go. We're going to go ahead and add the camera control, just because I like to see what Six is looking at. So camera device, click the green Start button, and I can see Andreas. Say hi, Andreas. Excellent. Okay. So we're going to be writing our program in the Blockly workspace. So under File, I'm going to click on F9 or Blockly. And now we have a blank canvas. And we can see in the camera preview, we can see Andreas. I'm going to go and put Six on our obstacle course. You can see that I've placed Six in the middle of a clear area. So there's a big strip of clear space in front of him. This is because to start, we have to understand how our robot moves when it moves forward, back, right, or left. We need to know how long it takes and how much room it needs. To start, I'm going to add the move forward block. And I've got my left speed, my right speed, and the number of seconds I want to move forward for. I want Six to go through the obstacle course fairly quickly, so I'm going to choose a speed around 225, which is almost top speed for Six. And I'm going to choose a time of 4 seconds, so 4,000 milliseconds, and I just want to see how long or how far Six can get in those 4 seconds. So click the green Start button to execute. So in 4 seconds, Six can go about the distance of one of the blocks that we've got on the floor. Okay, good. So now I know that time. I'm going to delete this block. And now I'm going to add the turn right speed block from movement. And this is where I choose how fast I want Six to move right or left. So again, I'm going to choose 225. And then under movement, I'm going to scroll down to auto position for a certain number of seconds. And left and right are actually auto position movements for Six. So let's choose turn right for, I'm going to guess about 6 milliseconds. I know because I've done tests before that this is roughly how long it's going to take Six to execute a complete 90-degree turn. But let's test that to make sure it works. So click Start. So that was actually a little bit more than 90 degrees. So I'm going to change it to 5 seconds, and let's just try that. Okay, that was pretty close. So this is an example of how we might have to tweak the values for our robot. Now that we understand how far our robot can get at the speed we want, and now that we understand how long it takes to execute a 90-degree turn in either the right or the left direction, left will be the same, now we can go ahead and write the full program for what direction we think the robot will move to get around these obstacles. So I'm going to clear my sketch. And let's just take a look at our obstacle course again. We want to start forward through the pylons. We want to turn to the right and then come forward to Darth Vader. We want to move left so that we can go straight down the path in the middle. until we get past Wally and the green blocks. Then we're going to turn right. We want to go straight between the final pylons and the yellow pylons before we do a final turn left and back out the final pylons. Okay, so let's do the first forward movement. So move forward, and again, I'm going to choose a left and right speed of around 225. And I'm going to go forward for about 1 second. He doesn't have very far to go before that first obstacle. And then we're going to add our turn speed because we're going to turn to the right. So turn right speed. Again, we're going to set 225. And then we're going to choose auto position, turn right. And I know I'm going to need about those 5 milliseconds is what we thought. Maybe 6, maybe 5,500. We'll play with it once we actually run the code. Okay, now I can right click to duplicate my code segments, which is great. It'll keep my speed setting. And I'm going to move forward towards Darth Vader. That's a pretty long distance. Let's go forward for about 6, 7. Let's do 6.5. So once we get to Darth Vader, we have to turn left so we can go down the middle. So again, we're going to go into movement and choose turn left speed, 225. And then we're going to duplicate auto position left. And again, we'll do about those 5 milliseconds. So we've turned past Darth Vader, and now we got to go right down that straight path. That's a pretty far distance. Probably need more than 10 seconds. I'm going to say let's give it about 12. So we're going to duplicate and move forward. Same speed. I'm going to move forward for 12,000 milliseconds. Remember that we're always in milliseconds. Now we need to turn right again and go down. We've gone past Wally, and we're going to go down in between these yellow pylons. Auto position. We're going to turn right for, let's go about 5 milliseconds. And then we've just got our second last forward. We're going to come down the pylons. I'm thinking about 5 seconds again. Okay, and now it's our last turn left and go straight. So turn left speed, duplicate again, auto position left. Again, we think it's roughly about 5 milliseconds to do that 90-degree turn. And then the last thing we're going to do is we're going to move forward, and I want to make sure we get through that finish line. So let's move forward for 5 seconds. Okay, so now that we have all of our code blocks, we're going to go ahead and run the code, and we'll see if any of our speed or time settings need to be adjusted. We might run into some obstacles, and this is our chance to kind of do some trial and error. I'm going to go ahead and place 6 at the starting gate. Let's click that green start button to execute our code and see what happens. All right, coming towards Darth Vader. Good, we made it through those obstacles. Turning left. Now down the long path. We'll see if we need more time or not. Oh, looks like 12 seconds was maybe not quite enough. I think we're going to run into those yellow pylons. Oh, maybe not. Oh, and we didn't go forward enough at the end. All right, so he's going to run right into that pylon. All right, I'm just going to stop my code here. So we can see from that run that we might need to adjust some of our speed and time settings. And if you want to follow along with your code, remember you can always look at the terminal window at the bottom. I'm going to go ahead and tweak some of those settings, and then we'll see 6 do his final run. and go. In this episode, we showed you how to navigate an obstacle course using a program built in Blockly. I used Revolution 6, but you can use any of the Revolution robots for this activity. We built an obstacle course using other robots, pylons, and even some foam blocks. We put down foam as a surface because the robot may have trouble getting traction on our floor. If you have something like tile, the robot might slip in between those tiles, so consider that when you're building your course. Always start with a fully charged robot to make sure you have enough battery life to make it through the entire obstacle course. Load Easy Builder and bring up the Bear project for your robot. The Bear project is a nice clean workspace with minimal controls. If you want to see what the robot is looking at, go ahead and add the camera control. We built our program using the Blockly workspace. Before we could create the navigation program, we had to understand how our robot moves when it's moving forward, backwards, right, or left. Place your robot in an area without any obstacles and test the movement forward. Choose a speed depending on how fast you want your robot to navigate the obstacle course. I wanted 6 to move pretty quickly, so I chose 225 as my speed setting, almost near the maximum speed for 6. Choose a time, maybe 2 seconds, maybe 5 seconds, and then click the green Start button to execute the code. You'll then get a chance to see how far 6 moves in that 2 or 5 seconds that you chose. This gives you a rate of movement, distance over time. To create a test for turning left or turning right, go into Movement and choose Turn Left Speed or Turn Right Speed. This allows you to set the speed setting for the turn movements. Within Blockly, Turn Right and Turn Left are actually auto position controls for 6. Choose Auto Position and choose your Turn Left or Turn Right movement, and then choose how long you want the robot to turn for. A 90-degree rotation will probably take between 5 and 6 seconds. Again, click the green Start button to execute your code and see how long it takes your robot to move 90 degrees. You will now have a rate for your robot's turn movements, how many degrees it can move in a certain number of seconds. Use this information to extrapolate for your other turns. Maybe you only want your robot to move 45 degrees. You just have to divide that time value by 2. Now that we understand how the robot moves when it's moving straight or when it's turning, we can build the whole program for navigating the obstacle course. Use your previous calculations to estimate the time values that you'll need to put into all of your movement blocks. Run the full program to see if any of the values need to be tweaked. Maybe your robot is moving into obstacles, maybe it's just clipping them on the side, or maybe it's completely way off track to what you thought it would be. Use this trial and error to tweak these settings until you've adjusted them to successfully navigate the course. Once you've adjusted all your settings, do a run to see if your robot can make it through the entire obstacle course. This activity has a lot of practical applications. For example, we might have situations where we can't have a human controlling the robot the entire time, and we need the robot to execute a specific movement or specific path with just one touch of the button at the beginning. For example, in a rescue scenario, maybe there's been a mudslide across a highway. You can tell the robot to go forward and move around the obstacle so that you can see what's on the other side. Another example is exploration on other planets, such as Mars. We can't be controlling the robot in real time because of the distance, so we can send specific navigation parameters to the robot, which it will execute on its own time and send back the information that it collects. Once you've completed this activity and learned how to navigate around obstacles, you can use this information for your other robot program activities. Thanks for watching this episode, and we'll see you next time. How do you calculate rate of movement? How many degrees of movement is a complete right or left turn? What is the practical application of obstacle navigation? Find the answers at therobotprogram.com.